Okay, so welcome back, everybody. We are going to stay at the topic of code generation, but in another language, Swift. As you might know, the Swift team introduced Swift macros at the end of last year, which are a completely new native way of generating Swift code. And my name is Kolos. I work as an iOS developer at Supercharge. And recently I had the chance to dive a bit deeper into the world of Swift macros by open sourcing my first project, which is called Mockable. It's a Swift macro-based testing framework. It's a unit testing framework. And it utilizes Swift macros to generate mock implementations for your protocols. Today, first, there is a great vision document in the Swift Evolution Forum, which discusses the place of a feature like macros in Swift. And I will share some ideas from it in short. And then we are going to go through my 5 steps of developing macros in Swift. And I simplified the Mockable macro and made it a bit comprehensible, but the idea is the same. So I will basically tell the story of me creating Mockable. And I forgot to ask my show of hands question. So how many of you would say that you are comfortable writing Swift code? I'm very curious about this. Okay, that's great. I saw one LiDAR, but never mind. Okay, so let's jump in. Why do macros even exist? First, let's talk a bit about different language features. You can categorize new language features into one of these 3 categories. They either fill in gaps. These are features that take some non-existent and not permitted syntax and give it some kind of semantics that fit well with the language. A good example of these, for example, is conditional conformance of protocols. There is another category which introduces completely new capabilities. For example, the new Swift concurrency system would fall into this category. Or reflection was a feature that brought a completely new capability to the language. But what we are interested in today is the third very big category, which is the syntactic sugar category. These are language features that help you avoid writing repetitive boilerplate, or they take something that was tedious to do before and make it easier. I brought 3 examples for this category. The synthesis of our most commonly used Swift protocols like codable or equitable is a merely syntactic feature, or property wrappers which only encapsulate complex property access logic is only syntactic. And of course, result builders which help us write Swift UI code that look less like a Christmas tree is only there to make our code look nicer. So, macros exist in many different languages, and what they all have in common is that they have the effect of democratizing syntactic sugar. So they basically democratize this third language feature category, by giving you, the user of the language, the power to create custom arbitrary language features that add syntactic sugar. And as a result, from a language design perspective, they will reduce the desire for these syntactic sugar type language features, which as a result will keep the language smaller and more focused, yet keep it expressive, and of course leave more time for the language developers, so the Swift team, to work on some more transformative work, which is surely needed, for example, with async await and achieving the compile time safety of race conditions, which is currently the biggest goal of the Swift team. So let's look at macros in Swift. Macros exist in many languages, for example in C, but C macros are very different. They operate on a lexical level. Your program text goes through several representations as you compile it, and the macro has to decide what level it operates on. And as opposed to C macros, which has a limited purely textual expansion mechanism, Swift macros operate on a syntactic level, and they operate on already type-checked Swift code. What I think the coolest fact about Swift macros is that the macro implementation itself is a program written in Swift, and it's run in a sandboxed environment, but you write macros using Swift. Macros have distinctive use sites, so you can always know you see a macro in code if you see a pound sign or an @ sign. Macros are always additive, like Chubby said, in case of Kotlin. So here we also have this limitation. Macros cannot remove existing code. They can only add and extend declarations. And in Swift, we can implement macros in a separate package as a compiler plugin. And we need to use a new kind of target definition, the macro target, and the library called Swift syntax, which I will elaborate on later. So let's see macros in action. There you can see the first example of a Swift macro. It's a freestanding macro. You know it's a macro because of the pound sign, and it's a single argument. And as I said earlier, you implement macros as a compiler plugin. The first thing the compiler will do is to send the source code of the whole macro expression to your plugin. Then the plugin will parse this into a Swift syntax tree. The Swift syntax tree is a source-accurate structural representation of the source code. As you can see here, this macro expression is represented in the Swift syntax tree as a macro expansion expression, and it has a single argument, which is an infix operator expression. Then comes your macro, which you implement in Swift, and you can implement arbitrary transformations on the syntax tree to produce a new kind of syntax tree. In our case, we are going to generate a tuple expression that will contain the same expression you passed in as an argument, so this infix operator expression, and also a string version of that. And as the last step, the compiler will serialize back this syntax tree and replace your macro with the result. So with the foundations done, what's next? I'm going to share you my step-by-step process of developing macros. We're going to take a look at a simplified example of the mock cable macro. And along the way, I will share with you some tools and tricks that can help you crafting your first macro. And my goal is that by the end of this, you will feel comfortable getting into developing your first macro. So how do we begin? First of all, we need a plan. And that starts with finding a good problem that is appropriate to solve with Swift macros. As I see, there are two good ways of finding these kind of problems. You can take something that you already generate with existing code generation tools. On iOS, there are already some code generation tools. I think the most popular one is Sorcery. And you can say, like I said, in case of mockable, I want to replace a problem which I solved with Sorcery with a native macro solution. So this is the easier way. Or you can search for some kind of boilerplate pattern in your code. One problem I just came across this week is the registration of SwiftUI environment values, which is completely just boilerplate. And you can find many of these kind of patterns in your code and decide on trying to solve it with macros. But if you find a boilerplate pattern, my suggestion is that you first try to solve it with existing tools. There are many very powerful tools in Swift, like property wrappers or result builders, or using a good architecture, which can solve many problems at a much lower cost. So first try to solve it with existing tools. But let's say we have jumped on the conclusion to solve it with macros. And then the first thing you should do if you decide on writing a macro is to write the expansion or the result of the macro first. This is very important. I actually made this mistake with mockable, jumped into crafting the macro itself too quickly, and I had to go back and refactor most of my macro implementation, which was not fun. So take your time and think about the design first before you start developing your macro. So let's see the example macro we are going to do today. Let's say we have a protocol which is called user service. It has two requirements, a fetch all and a fetch function. And we will generate a structure called mock user service for it that will contain a stored integer property for each of the members. If you don't know, mocks that are used in unit tests always need some kind of storage that will store the invocation count, which you can later verify. So that's what I was trying to mimic with this example. And also, this is comprehensible in this short time. So we're going to implement this macro today. Then we have wrote our desired result. The next thing we need to do is to choose a macro role. So what on earth are macro roles? There are two big categories of Swift macros. There are freestanding macros and attached macros. Freestanding macros are standalone, like stringify. They can act as expressions or declarations, whereas attached macros, as the name suggests, are always attached to something. And they have, instead of the pound sign, they have an attribute syntax. And both of these categories have subcategories, which we call macro roles. And they were created and categorized by what each macro generates and where it generates it at. You will see all the roles in a bit. And these macro roles have two advantages. First, they can help the compiler optimize macro expansion. And secondly, they are the basis of the implementations. So we have two freestanding macros. Expression macro, for example, stringify, is an expression macro that acts as an expression. So usually some code that is after the equal sign. And there are also freestanding declaration macros that you can use to generate function declarations inside the type or even global scope declarations. And I brought you an interesting example. It's the URL macro. And the URL macro will generate a non-optional or non-nullable URL value. And it will actually give you a compile time error if you pass in an invalid URL string. And I want to note here that this is also matches with the direction Swift is going. So one good use case of macros is to implement complex compile time checks, which were impossible before. And yeah, attached macros have a bit more different roles, but the names actually tell you everything about each role. So peer macros will always generate peers. If you attach a peer macro to a function, it will generate a function next to it, or a peer. And if you attach a peer macro to a type, then it is expected to generate a type next to it. There are also accessor macros, which will generate getters and setters. With this, you can basically re-implement property wrappers if you want. By the way, given macros existed before, property wrappers and result builders and all the other examples I've showed you would probably be implemented with macros. And moving forward, there are member attribute macros, which you can use to deprecate every member of a protocol with a single line, which is really handy if you're a library developer. but we also use member attribute macros to apply macros with a macro. If you are using the new observation framework in Swift, the observable macro is actually a member attribute macro also, because it will add the observation track macro to every stored property. So that's another common use case of member attribute macros. And the last two, we have member macros that will generate members inside the type, and extension macros, which you can see Xcode fails to highlight correctly. But extension macros were formerly named conformance macros, and they changed it and generalized it in the last minute to extension macros. Regardless, their main use case is generating conformances to protocols with extensions. And here are two attached macro examples. If you are not familiar with Swift macros, you can expand them with Xcode. So you can directly see the generated code inside the IDE. And that's what you see in these examples. On the top, we have an extension macro that will generate a conformance to the equitable protocol. And on the bottom, we have a peer macro that will generate a peer to the function you attached it to. In this case, it will generate the same version, a completion handler version of the async function you attached it to. And I have a question to test your attention. So this is our plan. We are planning to generate a mock implementation for our protocol. And what do you think is the appropriate role for this macro? Sorry?
What do you mean, like in testing or?
No, so we are right now trying to implement this macro. So this is what we want to generate from this source. And we need to determine a role for it. Okay, I will spoil it. The correct role for it is a peer macro, because we will generate a peer for the protocol. So we will generate a declaration on the same scope as the protocol lines it. And that's why the appropriate role is the peer role. So with the role determined, we can write our macro declaration. Here you can see the macro declaration for mockable. If you don't look at the right side, it is almost indistinguishable from a function declaration. First, we use newly introduced attributes to specify the role. Every macro needs a role. And by the way, a macro can have multiple roles. What's important is that you have to match the functionality of your macro to the appropriate roles and list all the roles your macro does. So, but currently we only need one role. We are only generating a peer, so we say to the compiler that this is a peer macro, and then we have the macro declaration. This is very similar to function declarations. Mockable don't have any parameters, but if you look at the macro declaration of stringify, it can have a generic argument clause. It has a parameter clause, and expression macros are special because they can even return a value. Expression macros will produce some kind of expression, and the result will be type checked against this return value. But this is really just a function declaration syntax. And lastly, if you might remember, you need to implement macros in a separate module using the new macro target, and you have to specify the target here, so the compiler will find your implementation. And you implement macros with a custom type, which you need to specify here. With that, we are done with our macro declaration, and we can start implementing it. So first off, this is a Swift package manager manifest file, and there you can see the usage of this new type of target, the macro target. We name it. It's very important to use the same name as you used in the declaration. And we need only one package dependency, but two products from it, the Swift syntax library, which I'm going to show you in action shortly. But first, let's see our macro implementation. So here you can see the signature of our macro implementation. It's a struct, but it could have been an enum or a class. It depends on you. And in your macro implementation, you need to conform to a protocol that matches your macro role. So every macro role I have listed has a matching protocol on the implementation side, and you need to conform to these protocols. Given this macro was doing 2 or 3 roles at the same time, we would need to conform to 2 or 3 protocols here. But we only need the peer macro protocol right now. And it has a single static requirement, which has 3 parameters. The first one is the node, which has an attribute syntax. This is the macro itself. So this is the @sign mockable. Next, we have the declaration. Since attached macros are always attached to declarations, in the implementation side, you get the declaration they are attached to. It has a generic declaration syntax type, so we don't know what kind of declaration it is. And lastly, we have this parameter called context. You can use this to produce complex diagnostic messages, which is really fun. You can, if you use Xcode, there are some trivially fixable errors which you get fix-its for. So if you get the compilation error, there is a fix-it button, which when you click will fix your error. And when you implement custom macros, you can implement this functionality yourself. And if you know that your macro has some common misuse usage, you can generate a custom fix-it for it. And this is what context is for. And the most important part, if you remember the high-level process of macro expansion, you need to return the transform syntax, and this is what we're doing here. We return an array of declaration syntaxes as a result of our macro expansion. And lastly, you need to provide an entry point for the compiler, which it will use to search for macro implementations. So let's do a short recap. So we have planned our macro and wrote the final version of it before we started doing the macro implementation. We identified its role to be a peer macro. Then we have wrote our macro declaration, and then we have created a new Swift package with the macro target, and there we have a currently empty implementation of our macro. So let's now jump in and write the body of our macro implementation. For that, we need to use Swift syntax. So what is Swift syntax? Swift syntax is not new. It has been around for a while. Tools like SwiftLint or even Sorcery use it to operate. And it is a tool written in Swift that can be used to parse, inspect, manipulate, or generate Swift code. And it is kept up to date as the language evolves. And it's nothing more than, it can be intimidating at first. So when I showed one of my colleagues the implementation of mockable, he said, this is magic for me. Because it uses many result builders and interesting stuff. But so it can be intimidating at first, but Swift syntax is actually nothing more than interaction with the language you already know. So if you write Swift code, you know Swift really well. And for that reason, I think getting into working with Swift syntax is not that hard. And an advantage I noticed throughout working with Swift syntax is that it can even help you understand Swift at a deeper level. And it also helped me correct, it also teach me the correct phrases for some of the Swift syntax's terminology. So To go back, I mentioned that the declaration we get in this parameter is a generic declaration. It is of type, all we know about this declaration is that it is some kind of declaration syntax, but this is not what we want, because we want our macro to be used with protocols only, and we want to prevent the user attaching our macro to a function or a structure. So the first thing we do is that we cast this declaration to a protocol declaration syntax type, and if this succeeds, then our macro was attached to a protocol. If it fails, then we throw an error. And throwing this error here means that the compilation will fail. Now, with that out of the way, as I see, there are two kinds of tasks that you will do when developing macros. You will either dig through syntax to find out some kind of information, or you will craft new syntaxes. So let's see an example for both of these. First of all, digging through syntax. The first task we need to do to implement our macro is to obtain a list of names for each of our requirements. So to obtain a list of names for our requirements. So in this case, we want to obtain a string array with fetch_all and fetch in it. So how on earth do you start doing this? There is a great trick you can do. You can run your macro from the unit test, which will be automatically generated for it. And you can stop the debugger inside the expansion of the macro. And you can use the debugger to experiment with the syntax you have been given. And in this case, I'm printing out the members of the protocol declarations. And you can see that we have a fetch_all right here. So all we need to do is to map this and filter out the necessary information we need. And playing with this, with the debugger a bit, you can arrive to this conclusion, where we first get the name of our protocol, and then we get a list of the names of the protocol members. First, we map out the declaration from the members. We, in this example, expect all members to be functions. This is, of course, not correct. And if it's a function, we can get the name as a last in the last map function. And with this information dug out, the next type of task that you will do is to craft new syntax. So we have all the information we need to generate this structure. How do we start doing it? And for that, I have a tip for you. There is a great online website called the Swift AST Explorer, which is that simple. There is a text field on the left, which you can use to pass in arbitrary Swift code. And on the right, real time, you will see the syntax tree. And what's cool is that you can also hover over a particular declaration and see all of its properties. And this tool helped me much when writing mock cable, because with this you don't have to always use the debugger to find out information about complex syntaxes. So you can use the syntax tree you see in this tool and directly map it to Swift syntax code. So writing Swift syntax code is very easy using this technique. You start from the top, and each syntax has an initializer, and you just need to fill in the required parameters in the initializer. So here we start with first the members of our structure. We create a member block item list syntax, and then we iterate over the member names, which we dug out previously, and create a variable declaration for every member with the count prefix and with the type integer. And as you can see, Swift syntax utilizes result builders. That's why you see the curly braces after the member block item syntax. And This is really cool, and it greatly simplifies constructing syntaxes. And with the members done, we can finally create our final struct declaration. We give it a name, which is the same name as the protocol name with the mock prefix, and we give it the members we've just created. So let's see what we have done. We have checked if our macro was attached to a protocol and thrown an error otherwise. We have used a debugger to cook this code and obtained an array of member names. And then we use this information to craft a completely new kind of syntax. And finally, we returned it as a generic declaration syntax. And with this, we can be happy, and we can appreciate our macro, except that when you do this, you get this compilation error, which I also ran into. And it says that the mock user service we have just generated is not covered by our macro mockable. At this point, I started checking the documentation, which has no information whatsoever about this. But then, in the Swift evolution proposals, I found the answer. And this was lesson number 1. Peer, member, and accessor macros. These are the macros that create declarations. They all require a names argument that will list all the names they will generate. And after an hour of search of where I should put this names argument, I finally found it. You need to add it to the role attribute. And these are called name specifiers. And the documentation currently is already extended with this information. And you should describe naming rules for your macro that describe what kind of symbols your macro generates. And at this point, the Xcode suggested me arbitrary at first, and I was like, okay, I don't really care. I will try arbitrary. And if you do this, then you will run into this second error, which says peer macros are not allowed to introduce arbitrary names at global scope. And this is very important. This is the biggest limitation of macros. Peer macros that are attached to top-level declarations, like a protocol that sits in a global scope, they cannot generate arbitrary names. And the reason for this is quite complex and very interesting. If you are interested in this in more detail, you can find the edge case examples for this issue in the proposal. But in short, if this was possible, then the type lookup system and the macro expansion together would be extremely prone to circularity. So this is not possible. You can never introduce arbitrary names at global scope with any macro. And arbitrary means that names that you can describe with the name specifier rules. But in our case, fortunately, there is a name specifier rule that we, by accident, already follow. It is the prefixed name specifier that will basically say that this macro will only generate new symbols that has the same name as the declaration you attach this macro to, with the only difference being a mock prefix. And with this, the compiler will be happy, and we are ready with our macro. And if this GIF starts from the beginning, this is how you can expand the macro in Xcode. You can even do this with the observable macro if you are interested in the internals of it. So with that done, my last topic is testing macros. Fortunately, Swift macros support unit tests by default. You can imagine these as snapshot tests, because that's what they basically are. And they are almost no effort to write, and they can prevent you from breaking your macro over time. So I highly suggest using them. And Swift macros test support is the original Swift syntax library that contains the testing support. And there is another very cool library I suggest using. It's the point freeze Swift macro testing library. And here's a test for a macro. Macro tests operate on string literals. You basically write your macro usage code on the top, and on the bottom you write the expected expansion. If you imagine writing the bottom part with your hands is really cumbersome, especially with a complex big macro where you have like 20 unit tests. That's unmanageable, because if you break one thing in your macro, you would have to update 20 tests, which are string literals. And the point-free guys recognize this issue. So their library, which is called Swift macro testing, will automatically generate this expected expansion if you change a isRecording flag. That library is really magical, so I highly suggest checking it out. And finally, I want to show you some resources. If you are interested in macros, there is a Swift Awesome Macros GitHub page, which was created by the guy who created Sorcery. And you can find all the resources you need for creating macros, and also a big list of existing cool macros. And if you are interested in the real implementation of my library mockable, and you want to see a complex macro in action, then feel free to check it out on my GitHub. And thanks for your attention.